So 2.2 is on the power rule. So I'm going to start off first by reminding you that although I have used d dx of x to the n, remember that I could write that as f prime of x. I could write that as dy dx. So remember all those different notations that we did in the last lesson. This just happens to be the one that I've chosen. And what I'm going to do is I'm going to alternate between the different notations so that you're familiar with them and you get to see that they all mean the same thing. So what we have in the box here is basically the general way of applying the power rule. Do you see the power rule? Sounds familiar? We've done power rule when we looked at exponents. You're going to find a lot of similarities between what we're doing now and what you did with exponent laws. Because it's kind of like the opposite of working with exponents, and you'll see what I mean by that. So what this is saying, and I actually think the easiest way to show this is with examples, but I'll quickly explain what's in the box. If you have some function x to the power of n, so this is the actual parent or initial function we'd be taking the derivative of, then for the power rule, all we would do is take the exponent that's at the top, and we would put it in front of the variable, and then to deal with the exponent at the top, you would simply subtract 1 away from it, and that's what you would have left. So let me show you what I mean with an actual example. So for the first one, if we have f of x equals x squared, and we want to find f prime of x, so basically we want to find the derivative, then what this is saying is for f prime of x, it would be equal to me pulling down that 2, so I'd have a 2 here, x, and then it would leave me with 2 minus 1. So again, there is no way that I want you to actually write this out when you're going through your work. This is just me teaching you or showing you all the details of how this is going to come up. But when we do simplify and clear this up, what that means is that our derivative of x squared ends up giving us 2x for an answer, because we did that 2 minus 1 at the top. And I chose to start with a function that we already looked at in the last lesson. But remember how we went through it in the last lesson with the limit as h approaches 0, blah, 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 blah. Don't you prefer this method? So now you see what I was talking about. This is actually much easier. And we end up with the same end result, which is this 2x. And so again, referring back to the last lesson, remember the parent function was the parabola, and then beside it we graphed that linear function, which was the 2x. Is it all kind of coming together? Okay. If we have then f of x equals x to the 5, following the same rule, if I want f prime of x, I think we can, well, no, I'll do it this time. I pull the 5 down in front, the x is still there, and at the top, I just subtract 1 from it, because that's what the power rule is. So, when we go to write our actual answer for f prime of x, or the derivative, we would get 5x to the power of 4. That's the derivative, f prime of x. Pretty good so far? I'm flying through, but I feel like you can see why I'm flying through. Okay, next one. What if we just have f of x equals x, and we want f prime of x? So like, what is the derivative when there's no exponent written there? Well, which exponent is actually there, even though it's not written there? It's actually x to the 1. So we could go through and do the same thing where it's like we have a 1 in front, which feels ridiculous because we don't normally write that. But at the top, it would be like saying 1 minus 1. Do we get that? So we're still doing the same thing in the power rule. So really, where does that leave us? X to the power of 0, which is just equal to the number 1. So our derivative in that case would just be the number 1. That making sense so far? Do you see why I was eager to get limits out of the way so we could get to this stuff? Okay, here's another one that's a little bit weird. I've purposely chosen some weird ones. But don't let that throw you off. We're still going to do the same approach. Can I write root x with an exponent? What does it look like? So this is just f of x. What's root x written in a different form? X to the power of a half. Everybody good with that? So yeah, no big deal. We have a fraction in the exponent, but we still do the same thing. So if we have f prime of x, we would bring down that 1/2. So now I'd have 1/2 x. And again, I won't always do this, but I want to make sure that you get this. If I'm subtracting 1 from this, for your notes, I'll write out every single little step. 1/2 x. If I want to do 1 over 2 minus 1, I better do 2 over 2, right? And I'm running out of room, so I'm going to carry on up here. So then f prime of x is equal to 1/2 x. What do I get? I get negative 1/2, so this is kind of looking crazy. There's a lot of stuff going on. What is the best way for us to rewrite that, or what's the best form to give our answer in if that's what we have in front of us? Okay, so when we have let's do this. I still have the 1 over 2, so I'm going to have 1 over 2, right? If we want to make this part a positive exponent, I've got to move the x to the bottom. Everybody good with that? So it'd be like x to the 1/2. This to me looks ridiculous that I'm writing every single step. I don't need you to do this, but I do need to do this so you get it in your notes. Do you see that we just end up with 1 over 2 root x? Because x to the 1/2 we know is a radical, it's best to not leave it as a fractional exponent, but to change it into a radical. Yes?
Isn't it also you don't want to have a radical in the bottom?
In the denominator? Oh, this is like getting into a roundabout. Yeah, like we could then go times root x over root x and rationalize the denominator, and you're absolutely right. That's probably the best thing to do, but like, I'm out of room. We don't have time for that. I would accept this. How's that? Good? How about if we don't even have a variable? If f of x equals 6 and I want to find the derivative, well, let's start with this. We can always rewrite things however we want to. If I wanted to put a variable there, like force it in, what would be the exponent on it? It would be an exponent of 0. Does that make sense to everybody? So the reason I did that is, like, I haven't changed anything. That's still the number 6, right? So then if I want to apply my power rule, in this case, there's already a number out front. It's like I shove it off to the side and I deal with this part using the power rule. So it's like times 0, x to the 0 minus 1. Again, this is ridiculous. You would never actually write this down, but I want to make sure that you get where this is coming from. We actually don't even need to do anything because you have something times 0. What's going to happen here? The answer is just that it's equal to 0 after all that. Good? So when you take the derivative of a constant, remember that's what we would call, just when it's a whole number, the derivative is just a 0. On to some more weird ones. Notice that we are always dealing with exponents, so how can I rewrite this rational function to make it an exponent? It'd be x to the negative 1, right? So that's our first step, rewrite it with an exponent, and then we go through the same old process when we're going to find the derivative, which is bringing down that negative 1. So I'd have negative, I wouldn't normally write this, but I want to make sure you really clearly get what's happening. I would do minus 1 at the top, right? So I'm getting negative x to the negative 2. Again, I don't like that. What's a better way for me to write that or to give my answer? Negative 1 over x squared is our derivative after all that. Does that make sense to everybody? Good? Again, a little bit different because now there's a number in front. So if we want to take the derivative, we shove the number in front off to the side for a minute and pretend it's not happening. And we take the derivative, apply the power rule. Yeah, we are taking the derivative by applying the power rule to the other part here. So we have, I'm going to put it in brackets. Like, again, it's ridiculous that I'm doing this. You don't have to do this each and every time, but I want to make sure that it's super clear what is going on here. We would have 6, and then in here we would have 3, and it would just leave us with 3x squared. That's inside of there. And to make this super clear, the squared isn't applied to the whole thing. Do you see that these brackets don't really need to be there? So it's 18x squared. So, okay, all that didn't need to happen. Basically, we just took the 3, multiplied it by that, and took a 1 off of the exponent. Good? So that is our derivative. And then we have a coefficient in front, and we also have a fraction in the exponent. And I didn't call it f of x this time. I said differentiate y equals this. So I'm going to move this down here and say y prime equals. I'm going to shove the 6 off to the side for a second, pretend it's not there. And we're going to just take the derivative of this part. And for a second, we're going to separate them, and then we'll bring them back together. So we bring down the 8 over 3. 8 over 3. I still have the x. And then I want to do 8 over 3 minus 1. But in this case, because we're dealing with fractions, it's probably easiest if we look at it as 3 over 3, which is the same thing as just 1. Am I going too fast? We're good? Okay. So y prime equals, and I'm still going to live in denial for a little bit, pretend the 6 is not happening. We're just going to focus on the pink part. And we would have 8 over 3x to the 5 over 3 when we simplify all of that out. And then we can simplify things here. We are going to multiply these and combine this. I said we would bring it all together at the end. But 3 just goes into 6 twice, so that makes it easier than us going through the whole thing. So after all of that work, this just simplifies to 16x to the 5/3. We could change that to a radical if you want to. It doesn't matter, but if you leave it like that, I'm fine with it. If you change it to a radical, I'm fine with it. What I want to know is that you know how to take the derivative. So that is your work for this part.